do example number 2. All right, here we go. If I have e to the x minus e to the negative x all over 2 equals 5. All right, so I want to solve this, and I think our goal always is to get x by itself on one side of the equation and all the other stuff on the other side. And people always say, Mr. Adams, why do you say stuff? Don't you mean the numbers? No, sometimes we have other variables. That's why I say stuff. So clearly I need to multiply both sides by 2. So when I multiply this by 2 and multiply this by 2, these 2's cancel. And I get e to the x minus e to the negative x is equal to 10. Now there's a simple way to make all those e to the x's become 1 e to the x. Because I want to have 1 e to the x somehow. And it doesn't necessarily have to be e to the x. E to the something of x, right? I want 1x is what I want. So one way to do that is to take this whole thing and multiply it by e to the x. And whatever I do on one side, I got to do on the other. Now by doing that, I end up with e to the x squared, right, minus, now this becomes e to the negative 0, not negative 0, but 0. And do you guys know why it becomes 0? Because they cancel out, right? The shortcut is, oh wait, is it x squared? No, you don't multiply them. I gotta slow down here. Isn't it e to the 2x? Yeah. Because the shortcut is this. This is what I'm trying to remind you guys of, but I had to remind myself of this. If I say a to the m times a to the n, isn't that the same as a to the m plus n? Right? That's the shortcut? Okay. So if that's the case, then I'm going to add these two x's, which is just 2x. And then when I add these two x's, I get x to the 0. And then over here I have 10 e to the x. Well, e to the 0 is just 1, right? And so I could do something like this. Whoops. I could subtract 10e to the x, and I get e to the 2x minus 10, because I got 10 to the ex here. And then that's just minus 1 equals 0, right? You guys with me so far? Now, if you look at this thing, see, Mr. Adams got ahead of himself. That's why I made my mistake earlier. If you look at this thing, what does that kind of look like? In fact, what if I left it, well, we'll just leave it the way it is right now. What does that kind of look like? Yeah, it kind of looks like a quadratic. So it'd be nice if I could make it like a quadratic, right? So this is something that you're going to just, you probably wouldn't think of on your own. But it's really, isn't this the same thing? Is that right? If I push the 2 back through, it's 2x, right? E to the 2x. So if I think of it like this, then really, now it really starts to look like a quadratic. I got something raised to the something squared minus 10 times that something, and then minus 1 equals 0. Now we could think w equals e to the x. Now if we think that, then we would say that this could be written as this. Is that right? that make sense? Okay, so now I'll tell you this: we can't factor it. Not in a normal way. So since we can't factor that in a normal way, what we're going to do is we're going to use the quadratic formula. So now the quadratic formula is this. First of all, A is equal to 1, B is equal to negative 10, and C is equal to negative 1. So then we would say that W is equal to negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. So then W is equal to positive 10 plus or minus, what's 10 squared? What's negative 10 squared? 100, thank you. So this is 100 minus 4 times A times C, which is times 1 times negative 1, all over 2 times A, which is just 2, right? So we've got 100, is that 100 plus 4 or 100 minus 4 under the radical? Well, when you minus a minus, in other words, when I multiply this by the negative, it becomes plus 4. So now, I've got, and I get motion sickness watching that do that. All right, so now I've got W is equal to 10 plus or minus the square root of 104 all over 2. Now, 104 is really 4 times 26. So then that's the same as 2 times the square root of 26 all over 2, which is the same as 10 over 2 plus or minus 2 root 26 over 2. Which is same as 5 plus the square root of 26. But what was W? Do you guys remember? Do you guys remember what W was? Yes. E to the x. So really, technically, e to the x is equal to 5 plus or minus 26, the square root of 26. Did I solve yet for x? No, this is a long problem. This is only example number 2. How do I get that x out of there? Well, I can take the natural log of both sides. So if I say the natural log of e to the x is equal to the natural log of 5 plus or minus the square root of 26. That means I'm going to get 2 equations, and I'm going to get x is equal to the natural log of 5 plus the square root of 26, which we'll pull up on the calculator in a second, and or x is equal to the natural log of 5 minus the square root of 26. Yes?
Couldn't you not do 5 minus the square root of 26?
Huh?
Can't you not do 5 minus the square root of 26?
Yeah, I was going to come to that in a second, but I'm glad that you thought about it before I was able to mention it. What is the square root of 26? It's bigger than 5, right? So I would have 5 minus some number bigger than 5, which would mean that this is a negative number, right? And I can't take the natural log of a negative number. Okay. The reason for that is you have to remember that the natural log of x is really log base e of x equals y. Okay. And so if I say log base e of some negative number here, remember the relationship is b to the y has to equal this negative number. And it's very difficult to figure out what that y value is. And so generally we just don't do it. And there's a more formal definition as to why, but I shouldn't write -1, I should just write down negative. Right? There are a few instances in which we could raise a number to a negative number. However, raising e to a negative number, well, e is like 2.2. So if I raise it to a negative power, it just makes it a positive fraction. So raising e to any power, it isn't going to make it a negative number. Does that make sense to you guys? So really we only have one shot at this thing, and that's this. All right. So now this you could just plug in your calculator. Right? And so if you do that, if you plug that in your calculator and you take the natural log of 5, will somebody do that on their calculator real quick and tell me what you get? $2.31. Does that make sense to you guys?